So in our last lesson, we talked about solutions, and we talked about things that were dissolved in water, and we did some conversions between grams and liters and using the molarity. Today we're going to go on and we're going to talk about how do we do our stoichiometry problems when you have a chemical reaction that involves a solution. These problems are going to be maybe a little bit longer than the 4-step ones that we did before. These ones might be 4 steps, they might be 5 steps, they might be 6 steps, depending on what the question gave us and asked us for. But they won't be hard. I'm going to show you exactly how to do it. So let's talk a little bit about these things, and then we will take a look at how we solve these kinds of problems. So then we're gonna talk about reactions with solutions, and our target will be to solve stoichiometry problems that involve solutions. So the first thing I want to say is that some of the problems that we're going to deal with are going to give us numbers, are going to give us volumes that are not in liters, but they're in milliliters. Okay, if a problem gives us a number that's in milliliters, the very first thing we have to do is we need to convert it into liters. And so after you start with the number that they gave you, the milliliters, and put it over 1, in your second fraction, you're going to use what's called a conversion factor. Now there are 1,000 milliliters in 1 liter. So if they gave you a number that's in milliliters, your second fraction is going to look like this. It's going to be it's going to have 1 liter on top and 1,000 milliliters on bottom. So if they give you a number in milliliters, that's going to be your second fraction. Now, if they asked you to find the volume in milliliters, then your very last step, what you're going to do is you are going to, right before that, you will have a liters on the top, and your very last fraction will look like this, where you have 1,000 milliliters on the top and 1 liter on the bottom. So, that first fraction will take you away from milliliters to liters, and that second fraction will take you to milliliters from liters. So we're going to see how these work out. I'm gonna put together a map, and you're going to see the map, and these are built into the map. So if you follow this map that I'm going to show you next, you will go from what they gave you to what they asked you for, no problem. Let's take a look at that. All right, here I have a map of how to pretty much solve any stoichiometry problem that I'm going to ask you to solve. You start on this side of the map, and you're going to go to this side of the map to find what they asked you for, okay? You pick the unit that you're starting with, right? So if the problem gave you a number that's in grams, you start with grams. If the problem gave you a number that's in liters, you start at liters. If the problem gave you a number that's in milliliters, you start with milliliters. If the problem gave you a number that's in moles, you start at moles. And then you follow the arrows forward to get to what the question asked you to find. So if, let's say, the problem gave me a number in milliliters and asked me to find an answer in grams, my first fraction I would set up with the number that they gave me. My second fraction, I would start right here. My second fraction would be the conversion factor, and then I would have liters. My third fraction, I would use the molarity to change that into moles. My next fraction, I would use the chemical equation to get to moles of a different substance. And then since it asked me for grams, in my last fraction, I'm going to use the periodic table, the molar mass, to get grams of the other substance. So no matter what you start with and what they asked you to find, you can follow the arrows on this map to set up each one of the fractions to get where you're going. So let's take a look at some problems where they might give us some numbers in liters or milliliters, and they might ask us to get some answers in liters or milliliters. Okay, here's the kind of problem they might give us to look at. It says, how many milliliters of a 0.2 molar HCl solution would be required to react completely with 2.6 grams of CaOH2? Okay, first thing, I'm just going to kind of make a note here on the board that the concentration of HCl was 0.2 molar. So I'm just going to kind of write it right here. so that I've got it like in front of me and I don't forget it. Okay. Now the number they gave me I can start with was 2.6 grams of CaOH2. So I'm going to start with 2.6 grams of CaOH2. Okay. Well, let's make a little plan and see how are we going to go about setting up our fractions. So I have here the map, and we are starting with grams. So we're starting right here. Okay. First step I'm going to take is to go to the periodic table and add up the molar mass and get moles. So let me go to the periodic table and add up the molar mass for CaOH2. And let's see, calcium is about 40. Oxygen is about 16, and there are 2 of them. And hydrogen is about 1, and there are 2 of them. So I get 74 grams. So I'm going to put 74 grams on the bottom. And then, of course, 1 mole on the top. Okay, now I've got moles. Consult my map. I'm at moles. Now I'm going to want to use the chemical equation to get moles of the other substance. Okay, so on the bottom of this fraction, I'm going to want moles of CaOH2. And there's no number there, so it's 1. On the top, I want moles of the one they asked me about, and that was HCl. So you can see that's 2 moles. Okay. Now that I got moles of HCl, I got a choice to make. Am I going to go towards grams or am I going to go towards liters? Well, the question asked me to find milliliters. So from here, I'm going to go this way. I'm going to use the molarity of that solution to get to liters. Okay. And the molarity was 0.2 molar. So that's 0.2 moles and 1 liter. I'm going to want the moles on the bottom. So 0.2 moles and 1 liter. And finally, the question asked me for milliliters. So I am right here at liters. To get to milliliters, I'm just going to use my conversion factor. 1,000 milliliters over 1 liter. And it's that same chemical, HCl. Okay. Now I've got it all set up. I have what the question asked me to find. I have milliliters of HCl. Let's go ahead and work it out and see what the answer is. So I have 2.6 times 2 times 1,000 divided by 74 divided by 0.2. And I get about 351. And of course that is milliliters of HCl. So not too tough. You can see this one was, what, 5 fractions long? 1, 2, 3, 4, 5. They might be as many as 6 fractions long. They might be as few as, maybe 4 fractions long. So it depends on what they give you and what they asked you for. But follow the map, and you can solve any one of these problems. Let's look at one more example here. The chemical equation is still the same for this one. But now the problem says, how many grams of CaOH2 are required to react with 26 milliliters of a 2.1 molar HCl solution? Okay, so first let me just kind of note here that the molarity of HCl, it says is 2.1. So 2.1 molar. I'm just going to kind of note that so that I know that, have it in the back of my head. Okay, now the number it gave me there that I can start with is 26 milliliters. And that's 26 milliliters of the HCl. So I'm going to start with 26 milliliters of HCl. Okay, let's kind of plan where we're going here. So the question gave me milliliters to start with. So I'm going to start right here on the starting side. Here's milliliters. I'm going to use my conversion factor to get to liters. I'm going to use that molarity to go to moles. the chemical equation to get moles of the other substance, and then the question asked me for grams. So from there, I'll use the periodic table to get grams. So my first step here is to use that conversion factor. So I will put here on the top 1 liter of HCl, and on the bottom 1,000 milliliters of HCl. Okay. Now we said from there, we're going to use the molarity to get to moles. Okay, so the molarity of that solution was 2.1 molar, so it's 2.1 moles to 1 liter. I'm going to want the 1 liter on the bottom. So I'm going to put 1 liter and 2.1 moles. Okay. Now that I have moles, I'm going to use the chemical equation to get to moles of the substance they asked me about. And the question asked me about was it CaOH2. So on the bottom, I'm going to want moles of HCl, which is 2. And on the top, I'll want moles of the one they asked me about, which was CaOH2, which there's not a number there, so it's 1 mole. Okay. Now I have moles of CaOH2, so we're right here, and the question asked me to find grams. So now I'll use the periodic table to go to grams. I'm going to add up that molar mass. So we will add up the molar mass of CaOH2, which we just did a minute ago, and it was 74, I believe. So I'm going to put 74 grams up on the top here, and then 1 mole on the bottom here, so that moles match up. Okay. And now I have what the question asked me to find. It asked me to find grams of CaOH2, and I have grams of CaOH2. So let me work out the math here. I'm going to start with 26. That's times 2.1 there, and 74. And we're going to divide that 1,000, and then we'll divide the 2. And I get pretty close to 2. So that'll be 2 grams of CaOH2. There we go. That's a D. G for grams. So not too terribly difficult. Okay, so there's how we incorporate like liters and milliliters and molarity into our stoichiometry problems. So, follow that map. If you follow that map, you should be able to solve any one of these problems. No problem, right? Hopefully that helps us be able to solve stoichiometry problems that involve solutions. So until next time, take it easy.